the next question. So question number 8. Okay. Okay, so for this question, we're asked, what is friction? Write its formula in steps. So we're just kind of thinking about what friction is and all its type and the formulas associated. So there's 4 types, as indicated by the Junior Tutor. Let's go through the Junior Tutor's answer and then we'll verify how to think about this. So friction is a force resisting the relative motion of solid surfaces, fluid layers, and material elements. So this is kind of just a general idea. There's 4 types, so static friction, sliding friction, or kinetic friction. So I would say this one and this one are the most important ones. So I'll write that over here. So we have static, or the ones that you'll encounter the most, and kinetic. So for static is the force of friction that's acting in an object when it's at rest. So if you push on an object, you have to overcome the static friction for the object to move. But for kinetic friction is when the object is moving. There's a constant friction force that's acting on it as you're pushing on the object, so causing it to move. So I'll draw the first diagram here. So when you think about static, the stationary object, you're trying to get it to move. So for kinetic, the object is moving, so I'll draw like streaks. It's going this direction, but there's still a force of friction resisting. So we'll call this force of friction K, force of friction S. Oh, actually just write Fs and Fk. Okay. And then we have rolling friction and fluid friction. So these are also another 2 types of frictions. Usually you'll encounter static and kinetic the most. So what rolling friction is when something is rolling, when something is shaped like a circle, or when it's rolling on a surface. Rolling friction is much weaker than sliding friction or static friction. This explains why most forms of ground transportation use wheels, because rolling friction is a weaker force. So that's why kind of we have wheels on a car, because it's not as strong of a force. If you were sliding on the ground, you'd have to put more force to overcome that force of friction. You can see what this looks like in the figure. So this is just a bearing with a bunch of balls that use rolling friction when this thing turns. So you don't really have to worry about this as much. Just know kind of the general idea. And then fluid friction is the friction that acts on the objects that are moving through a fluid. A fluid is a substance that can flow and take the shape of its container. Fluid can include liquids and gases. So when something moves through a fluid, there is some kind of fluid friction that's acting on it. So usually you look at these 2 formulas for static and kinetic friction. That's kind of what most physics problems will give you, or what they will ask you for. So 2 formulas are as follows. So I'll write them down here. So Fs is the coefficient of static friction times the normal force. So when we think about normal force, I'll draw another diagram. So we have some box. We have the normal force always points perpendicular to the surface. And then we have the force of gravity pointing down. So in this situation, the force of gravity equals the normal force. We can substitute this in. One thing to note is the coefficient of static friction is different than the coefficient of kinetic friction. They're 2 different values. Oh, I made a little mistake over here. So this is Fk here. So this value and this value are different. That's why you have 2 different force values for friction. The main thing to note here is coefficient of static friction is higher than the coefficient of kinetic friction. And you can kind of think about this experimentally, or You can kind of do it on object. It takes more force to start the motion of the object than it is to keep it moving. And that's due to the coefficient of static friction being higher than the coefficient of kinetic friction. Okay, so we'll mark this question as correct. So correct answer. Great job. Okay, and this is the final question that we'll be going through. So we'll mark this as correct. Okay, so that was the final physics problem that we were going through. Hope you enjoyed this session and you learned something along the way. If you need any more homework help or you enjoyed this video and you want to learn more, you can subscribe to this YouTube channel, visit oneclass.com or the link in the description for any tutoring help or homework needs. So I'll see you in the next session, and hopefully you'll tune in to more OneClass sessions. And goodbye for now. See you later.